Hello, welcome everyone. My name is Vijay Dhama. I'm with my colleague.
Zufar Dhiyaulhaq.
Today we're going to talk about how in GoPay we automate mTLS communication with our GoPay partners using Istio. Uh, we both are working as SREs in a payments arm of Gojek called GoPay. As a brief introduction, Gojek is a super app which basically provides, which is basically a tech platform that provides access to a wide range of services like transport, payments, food delivery, logistics, etc. GoPay is basically the digital payment provider for under Gojek in Southeast Asia. We operate out of Indonesia, Vietnam, Thailand, and Singapore. In our agenda today, we're going to talk about GoPay and Istio role in basically setting up mTLS. Secondly, we're going to talk about how the world looked like before mutual mTLS. We're also going to talk about how we implemented our own mutual TLS setup in Ingress, Egress, etc. And we're also going to talk about challenges that we faced and the future work we expect to do after this. Now we're going to start with GoPay and Istio.
So in GoPay, we have a multiple Kubernetes cluster, more than 250 microservices, 3,000 deployment every week, and 150 million API calls. Also, we have both REST and gRPC services, and we have also service written in Golang, Java, Clojure, and Ruby. Basically, GoPay has been using gRPC since 2016, and we decided to use Envoy and console before to migrate a virtual service to container because it have ability to load balance traffic between the VM and container itself. Over time, managing Envoy and console become a slightly burden because we need to maintain all of the configuration for all the microservices that we have. We choose Istio as our service mesh because we are using Envoy before, we have an experience in the Envoy, and it's easy to migrate and adopt the existing Envoy filter using Istio. So we will talk about our previous setup in Istio.
Yeah, before mutual TLS, the setup that we had with our GoPay partners was either use VPN or use basically HTTPS with allow listing. Basically, what we did was have basically store NAT gateway IPs uh, from the our GoPay partner, and then allow only those IPs to connect to our and HTTPS endpoints. This restricted this improved the security of our endpoints, and we knew who we were allowing to connect to. Now, the issue with this approach is that you need a lot of maintenance effort in terms of managing those endpoints. So in case if the net IPs of our GoPay partners change, we need to update those endpoints, and vice versa if we need to do the same thing for our GoPay partners. This also is not a preferred approach suggested from our security team. So this is when we decided that we want to move away from this and move to mTLS, which is what our security team suggests. This also allows for internal attacks if the IPs can be changed, and that is not what we wanted. So now we will move on to implementing mutual TLS. The first step was we wanted we have this service called centralized certificate management service that is responsible for maintaining our mTLS certificates, renewing those certificates and updating those certificates back into our basically services. So the certificate management service is responsible for creating those mTLS certificates and store those in secrets so that services can read those secrets and basically mount those certificates onto the service. This makes it easier and makes the process hollow automated basically end to end, so that we don't have to deal with secrets anymore. And even short-lived certificates can be renewed and updated. Moving on, next we will talk about and jump on to Ingress mTLS.
Okay, so our mutual TLS setup in Istio, it's divided into two parts. The first is ingress and egress traffic. So for ingress traffic to our cluster, basically is external client calling our services using mutual TLS. We use gateway mechanism with mode mutual. Also, we leverage subject alternative name in the gateway manifest to verify the client son in case we are using public certificate. And we also can have additional IP listing if necessary in this setup. For egress traffic, we are using egress TLS origination concept from Istio. So the client in this case only need to talk with HTTP protocol, and the Istio sidecar will automatically upgrade the connection, the HTTP connection, to mutual TLS traffic. Add the certificate automatically. This is the sidecar, and we have mutual TLS connection working. The certificate in this case is mounted in the sidecar with annotation from Istio, so only specific deployment can talk to the server itself. Also, we will discuss about the challenge and future work for this use case. We counter a problem when sometimes we get 503 error in egress communication. So we try to debug this and we fix this by adding retrieve mechanism in the virtual service object itself. Also, in the future work, we plan to migrating the egress TLS origination mechanism to use egress gateway because we do not need to mount the certificate directly into the sidecar and just let the egress gateway handle the certificate itself. We cannot do this before because we are using Istio 1.6 currently, and the egress gateway is not support adding certificate via SDS. And yeah, okay. Thank you everyone. Please ask question in the Slack channel and give us some feedback. And thank you for following our session.